What if I told you that what we call autism may not be a permanent brain wiring difference, but a cellular defense state that never resolved? This is going to challenge everything you've been told, and I need you to hear the full explanation before you react. Dr. Robert Navio's research at UC San Diego identified the cell danger response as a fundamental metabolic shift when cells detect threat. It changes mitochondrial function, alters neurotransmitter signaling, shifts purinergic pathways, and rewires how cells communicate. To understand why this matters, you need to know what purinergic signaling actually is. Every cell in your body uses molecules called purines, ATP, and its metabolites as an extracellular language. When CDR activates, ATP is released outside the cell where it acts as a danger signal. It binds to purinergic receptors on neighboring cells, telling them there's a threat detected. In the developing brain, these same purinergic pathways regulate when neurons connect, when synapses form, and when immune cells, called microglia, prune excess connections. When danger signaling hijacks that system, the developmental program gets altered at its foundation. In his research, Navio demonstrated that when CDR activates in early development, whether in utero or in the first years of life, it can alter neurodevelopmental trajectory. So cells responsible for synaptic pruning, myelination, neural circuit formation operate under threat signaling instead of normal developmental signaling. The brain doesn't wire incorrectly, it wires for survival under the conditions it was given. And the microglia, the brain's resident immune cells, play a central role here. Under normal conditions, microglia sculpt neural circuits by pruning unnecessary synapses during critical windows. Under CDR activation, microglia shift into a reactive inflammatory state. They either overprune or underprune, and the result is altered connectivity, not a broken brain, but a brain shaped by an immune environment that was signaling danger during the exact window when circuits were being built. In animal models, Navio showed that blocking the CDR signal through anti-purinergic therapy with suramin made many behavioral and neurological features resembling autism began to reverse. Not in every case, not permanently with a single dose, but measurably and repeatedly. Navio's small human pilot study, published in the Annals of Clinical and Translational Neurology, showed measurable improvements in language, social interaction, and restricted behaviors in children who received a single low dose of suramin. The changes appeared within days and faded as the drug cleared the system. That pattern alone tells us something profound. If a metabolic intervention can shift behavioral presentation, the behaviors are not hardwired, they're state dependent. What this suggests is staggering. At least a subset of what we label autism may be a metabolic state, not a fixed neurological identity. The cell danger response triggered by environmental inputs, infections during pregnancy, toxin exposures, immune activation events that never completed its resolution cycle. And the research on maternal immune activation supports this directly. Animal studies consistently show that triggering an immune response during pregnancy, even without a live pathogen, just the immune signal alone, produces offspring with altered social behavior, repetitive behaviors, and communication differences. The immune activation itself changes the fetal metabolic environment. CDR provides the mechanism explaining how. I'm not saying this is every case. I'm not saying autism is caused by one thing. Biology is never that simple. But the CDR framework gives us a lens that the current model does not have. One that explains why some children improve dramatically when you address the metabolic environment rather than just manage their symptoms. This is the conversation the mainstream is not having. These children and their families deserve to have it. If this is the first time you're hearing this, follow. The research exists, and I'll be sharing more.